Objective 3. Explain how the interactions among species such as competition, predation, parasitism, and mutualism organize a community. And I'm going to apologize up front because this is kind of a lengthy video. First of all, what is competition? The two species are competing for the same resource, and so it's going to impact both of those species' numbers negatively. We've got predator-prey interactions, which would include predation as well as parasitism. One organism is going to eat the other. The predator eats the prey. So you're going to see an abundance in the number of predators or parasites. And it's going to reduce the numbers of the prey, which is the host organism. Competition happens when members of different species require the same resource, and that supply of that resource is limited. The competitive exclusion principle states that no two species can occupy the same niche at the same time. And you see here we've got all these different birds that are in that fir tree there. Resource partitioning happens where the resources are divided out to decrease the competition. You see how they are in different areas of that tree so that their niches don't overlap as much between the different species. You got them living in the bottom, at the tip top, down the sides at the top, right in the middle. So you got them in different areas, so it reduces the competition some. Owls and hawks eat the same thing, but you don't often find owls and hawks in the same area because they're competing for resources. In the predator-prey interactions, as we said previously, the predator eats the prey. So the predator's going to be bigger. It's going to entirely consume the prey, and it's going to have a lower reproductive rate. This is a way to decrease prey densities, is by increasing the number of predators. The predator population and the prey population can fluctuate in size. The size of the predator population is dependent on how many prey there are. Is there enough to eat? If there's plenty to eat and it's a steady state, then we're going to have plenty of predators to eat all those prey. But eventually what's going to happen is the predators are going to eat up all the prey. They're not going to have enough food, so they're going to become sickly and weak. And so then we're going to see the population of the predators start to decrease. And that's when the prey population will start to rise. An example of this is the snowshoe hare and the Canadian lynx. You see here in this graph, we're going from 1845 to 1935. Look at the number in the thousands that's along the y-axis. The purple is the hare. The blue is the lynx. So let's look at around 1855. You had a low population of lynx, had a high population of the hare. So what happened in 1865? Look what happened to the lynx population. It went up. Okay? It goes up. And then it'll naturally just come back down. You can see how, just looking at the hare population, how we have the spikes. And when it spikes up, that's usually when the hare population, or when the lynx population is lower. Now, prey have a lot of defenses that will maybe discourage predators from eating them. They have heightened senses. A lot of times they're very fast or have protective armor or maybe spines or thorns. Sometimes their tails or appendages break off. They can camouflage themselves. They can also, some of them will have poisonous chemicals that they give off, or warning coloration, or there are splocking behaviors as well. So anything to discourage a predator from eating them. You can see here, you got camouflage. You can't see that flounder there at all without looking very closely. Look at the warning coloration of that frog. That's a warning. And then look over there at that figure C. You see where the eyes are? And then look at the false head. That's to give the impression that it's a lot bigger, and that false head looks like it's got sharp teeth in it. So things aren't as likely to eat them if they look like that. Kind of scares them away. Mimicry is also something they use where they resemble another species to get a predator not to eat them. Batesian mimicry, they don't have the defense, but the organism that they are mimicking in their coloration is an organism that would be avoided. You see this with a king snake, the scarlet king snake, and the coral snake. The coral snake is very venomous. The king snake is harmless, but the coral snake is red on yellow and then black. But then the king snake is red on black and then yellow. So it's mimicking the coral snake. You also have this Mullerian mimicry where it shares the same kind of defense that the species that it is mimicking does. For instance, a bumblebee and a yellow jacket are very similar in colors, and they both can sting. So the bumblebee mimics the yellow jacket. Now, symbiosis, you need to have this definition. It's when two species live close together and interact with each other. You have different types of symbiosis. Parasitism, where one organism benefits and the other one is harmed. Commensalism, one organism benefits and the other one's not affected. And mutualism, where both organisms benefit. So what you're going to expect from this with parasitism, if you have more parasites, it's going to affect the host, and you're going to have a decrease in the host population. Commensalism, you're going to have the one organism that the population gets bigger, but the other one's not affected at all. And mutualism, both of them will experience growth of their populations. Looking at parasitism, now that's a dog's heart with heartworms in it. They don't get any nourishment from that dog's heart at all, but they live there. They are endoparasites. They live inside there. Also, ectoparasites is another one that you'll see, like leeches that'll get on you and attach themselves and suck your blood. So they do get nourishment from the host blood. Now, commensalism, one benefits, the other one's not affected. Like the clownfish here that you see in the sea anemone, like in Nemo, the clownfish has a habitat, okay? And it doesn't affect the sea anemone at all. Sometimes it turns out to be more mutualism or parasitism. You know those little white birds, the egrets, that are always near cows? Well, they're not actually, we know they eat the bugs, and so they benefit, but the cows actually benefit as well because the little egrets flush out the prey from the grasses and stuff around. They flush out all those little insects and things. So both of them are actually benefiting from that, so it would be more mutualism. With mutualism, again, both species benefit. It doesn't have to be equally beneficial to both of them, like look here at this fish. It's got that little fish in its mouth and it is cleaning that big fish. Um, they both benefit because a little bit, but the big fish doesn't benefit much, okay? You'll also see how different organisms can help each other obtain food. And like in your large intestine, you've got bacteria that you need in your large intestine, and your large intestine need that environment to survive. So you both benefit from that. So that would be mutualism.